Example 4 is on page 175. And all of example 4 is working on difference of squares. So again, the name of this is difference of squares, and we call it that because difference means subtraction, and we have a subtraction sign, and squares is because the first term is squared and the second term is squared. When you have a basic difference of squares, the only way to get a squared is a and a. The way to get b squared is b and b. One has to be positive, one has to be negative. And if you multiply it out, look at your outside and your inside, they end up being the same thing, but one is positive and one is negative. They cancel out. So you only get a squared minus b squared. Even if the first and the last things don't look pretty, but one of them is squared and the other one is squared with a minus sign in between, you can take the first one, 3x plus 4 and 3x plus 4. You can take the second one, 2y minus 1, 2y minus 1. One of them will be adding, one of them will be subtracting. But after doing that, we might have some like terms. Here, in the first set of brackets, we have 4 minus 1, so we get 3x plus 2y plus 3. And in the second one, 4 minus a negative 1, 3x minus 2y. Minus a negative is adding, plus 5. So again, I started with the difference of squares, and then I factored it and simplified it afterwards. Part C, we have two terms with a minus sign in between. So it should trigger for us, this might be a difference of squares. We have 2x minus 3 squared, and we have y minus 4 squared. So that should trigger for us that we have a difference of squares. But then when we look at the numbers in front, 27 isn't a perfect square. 75 isn't a perfect square. So initially this was looking like we should be able to use difference of squares, but we run into a problem because the number in front of this term, 27, isn't a perfect square. The number in front of that term, 75, isn't a difference of squares. However, if we do look at this first term and this term, is there a number that is in 27 that's also in 75? Is there a common factor that we could take out of those two terms? 3. 3 divides 27, 3 divides 75. So as a first step, I could factor out that 3. Once we're up to here, is there anything else we could factor? You would have to look in each individual one and see, is there something common in here? There's no number common between 3, 2, and 3. And there's no squares, so there's nothing left that we could factor. But it is something you do need to check. Could we factor it even further? So I take a 3 out. That will leave me with 9. 2x minus 3 all squared minus, take a 3 out of 75, 25, y minus 4 squared. You can do a quick check. If you distribute the 3 into the first term and the 3 into the second term, does it equal what we had to begin with? Yes. And now, what's inside the brackets is a perfect square minus another perfect square, because 9 is 3 times 3, and 25 is 5 times 5. So when I have my first ones, it'll be 3, 2x minus 3, and 3, 2x minus 3. With my last ones, it will be 5, y minus 4, and 5. y minus 4. One of them will be plus, one of them will be minus. And from there, can we simplify inside these brackets? We're going to get 6x plus 5y. Here I'm going to get minus 9. Here I'm going to get minus 20. Put those like terms together, minus 29. In the second one, we're going to get 6x. We're going to get minus 5y. Here I'm going to get minus 9. Here I'm going to get plus 20 plus 11. Math and algebra is about abstraction, looking for patterns. What we're doing in this question, I'm going to just zoom to the entire page. And what this is trying to get your brain to recognize that factoring this is the same idea as factoring this. Can you get your brain to see that? That they're the same thing, just one has bigger or more complicated looking numbers compared to the other one. This one, the first one, is something squared minus something squared. And it's as basic as we can make it. A squared minus b squared. This one's much more complicated, but it's the same idea. It is something squared. 3 times 2x minus 3 times 3 times 2x minus 3. Minus something else squared. So we can factor it in the same way. So one of the things we try to do in math is learn how to recognize patterns in a more complicated situation and then apply what we know about the easier situation and what that does. Okay, questions for practice on this one are 12, 13, and 14.